Hello, hello. Mr. Richardson here. Welcome to the last lab of the year. We're doing a specific heat lab. So I have a metal cylinder. See this here? It's a piece of iron. It's not going to come into play what it is exactly, but a piece of iron. And today we're going to figure out the specific heat of that metal iron cylinder. So I'll share my screen here with you. So you guys can see here's the lab that we're working with. So I hope you guys gather the data here and then set you loose to do your calculations. And that's it. That's the last task that we have for this year. So first thing we need to do is we're going to measure and record the mass of an empty calorimeter cup. So here is a calorimeter cup. Looks like a styrofoam cup, and it's got this nice lid that fits on top. Again, the whole idea of a calorimetry cup is that it, in theory, it does not let any heat in or out of the system. It's that nice fit of the cup, nice fit of the lid on the cup, and there we go. Theoretically, it's a nice insulated environment for us to do our experiments with. So I'm gonna find my my balance here. We're at zeros. Get this so you guys can see it as we find the mass of our calorimetry cup. We'll put the calorimetry cup on the scale there, and it reads 100.8. I'm sorry, 10.08. I've missed my decimal point there. So 10.08 grams. All right, a fantastic start. The next step is that we're going to take roughly 100 milliliters of tap water. The exact amount doesn't matter, so roughly 100 milliliters of tap water. Here's our tap. Watch you guys watch me fill up. Roughly 100 milliliters here. There we go, pretty close. Again, the exact amount doesn't matter, so we're pretty close to 100. I'm all right with that. Check there's some soap in here. Actually, dump that up, try it again. Didn't like getting all those bubbles. But maybe it's not soap, maybe we just have some bubbly water today. All right, so we got roughly 100 milliliters of water. And we'll pour it into our calorimetry cup. Put the lid back on, and now we'll find the mass of this. All right, so our mass of calorimetry cup with roughly 100 milliliters of tap water is 0.61 grams. All right, there we go. The next step we're doing here, temperature of this tap water. I'm actually working with two different calorimeters today. I got one for the ice water. That's this one here. We don't want that just yet. And here is the one we're going to use for our tap water. So what we're going to do is we're going to slide this temperature probe through the lid. And just take the whole system here into the calorimetry cup. Let that temperature adjust. And it didn't change much, which is absolutely all right. We'd expect tap water to be pretty close to room temperature. So 22.6 we'll record here. 22.6 degrees Celsius. The next step then is I've got a piece of metal and some ice water. You can see that there. So here's my piece of metal. It's sitting in the ice water. So the theory here is that the metal, it's been in there for quite some time now. So that metal should have the same temperature as the ice water. We're measuring the temperature of the ice water there. A little stir, make sure we're getting the most accurate temperature. And we can see from our temperature probe here that that is, boy, back and forth there, huh? One more quick stir so we can get it to settle. We'll call that 0.5 degrees Celsius. Temperature of the ice water, and that's 0.5 degrees Celsius. Now we're going to transfer metal cylinder, which again should be at a very cold temperature, into our calorimeter with our tap water. We'll watch as the temperatures come together. Now I'm going to use tongs for this. And the reason why I'm using the tongs is because I don't want to touch the metal because I will probably transfer some of my heat to the metal. So as I remove that cylinder from the metal and make sure I get all the water off of it, I don't want to take any of that cold water over. That'll change my results. Drop it into the calorimetry cup. Close the lid so that no heat is escaping. Make sure that thermometer's in there, and we'll see what happens to that temperature. Of course, there's something in the way. There we go, 21.2. Swirl it around a little bit, make sure we get an even measurement to that temperature. And it looks like we got a final temperature of 21.5 degrees Celsius. Just one more data point for you here. And now we are going to find the mass of the water, the calorimetry cup, and the metal cylinder inside it. Whole system on the balance here. Then record that mass, 161.83 grams. All right, guys, the rest of this lab is making calculations. You do not have to do them tonight, Monday night, assuming you're watching this on Monday. This is finishing up this lab, doing these calculations. It's actually our plan for the last day of school on Tuesday or Wednesday. So you can sit tight on these and do these with us in class tomorrow. If you just want to get them done out of the way, you can go for it now. Have a great summer. Stop in and see me next year. Cheers.